Dark matter is basically a profound underestimation of the real energy density of the geometric structure of electromagnetic propagation. We already know that photons, as they have no mass, they can be zillions and zillions of photons in a given point, all in the same place at the same time. And the closer that point it is from a radiation source, the more photons there are in that point, and the further away this point it is from a radiation source, the less photons there are in that given point of space-time. So what is dark matter? It's basically the sum, because there's one thing that we have to know first. We know that photons have no mass, but they do carry energy. And this is what Albert Einstein won his only Nobel Prize for his studies on the photoelectric effect, which, among many other things, states that photons do carry energy and that the energy is defined by its wave frequency. So dark matter is basically the sum of the wave frequencies of all the photons that are in a given point of space-time in the same place at the same time. And due to the fact that E equals mc squared, or that the energy equals the mass multiplied by the speed of light squared, and that's where the gravitational influence of dark matter comes from the fact that the energy density of electromagnetic radiation is so high that it generates relativistic effects. This perfectly explains why there is more dark matter in the center of the galaxies, because there are more radiation sources. This also perfectly naturally explains why there is less dark matter the further away we are from the galaxy center, because there are less radiation sources. This naturally explains why dark matter halos around radiation sources are spherical. This is because of the isotropic propagation of electromagnetic radiation. This also perfectly explains why the distribution of dark matter across the cosmos is filamentous, because it's basically the overlapping of electromagnetic wave fronts which propagate in straight lines. So it's natural, it's obvious that between two distant radiation sources there is a filament of dark matter, because it's basically the overlapping of the wave fronts propagating in straight lines. This also naturally explains why dark matter is transparent, or is invisible, or it doesn't interact with light, because electromagnetism is transparent to itself. Because photons have no mass. We already proved that with the pinhole camera. We can prove that when we open our eyes and we see around. This is also the reason why we didn't see it before, because dark matter is invisible, is transparent. That's the reason why we didn't see it, because we only see, our eyes or sensors or detectors or antennas or telescopes only perceive the wave fronts that made it straight into our retinas, sensors, antennas, telescopes. But in front of us, when I look in front of me, there is much more light than the light that I'm seeing. Actually, I see something like 1% of the light that is right in front of me, making it into my eyes. We can also prove this empirically. Yeah. Okay, so I'll stand right behind the camera so we all see the same thing. Now we see all the light that made it into the camera, into our eyes, but there's much more light than that. For example, I don't see the light propagating from the roof downwards, but it's right in front of me. There it is. This is an empirical proof that the light of the roof is here. I don't see the light propagating from the floor upwards, but there it is. The light of the propagating from the floor upwards is right there.
Yeah.
So finally, this also explains dark matter's coldness, because the energized points within space-time are defined by the frame of reference given by the radiation sources. So dark matter moves around with the radiation sources, with the stars, with the galaxies, with the galaxy clusters. So that makes dark matter cold. And that's it. That is dark matter. This is a very good case for an Occam razor, where the simplest explanation tends to be the right one.